This is Unit 9, Chapter 9, Safety. Working safety with electricity. Keep all your hands in both pockets, if that's possible. That's not really what it says. But 9-1, electrical safety. Roll it on, Howard. Let's go to the next section here. Electrical current through the body can disrupt the electrical function of cells. It can cause involuntary muscle contractions. Large currents can cause burns, skins, and heat tissue. This table, below 1 milliamp is generally not perceptible. Faint tingle at 1 milliamp, 5 milliamps, slight shock felt, not painful, but disturbing. Average individual can let go. Strong involuntary reactions can lead to other injuries. 6 to 25 milliamp amperes in women. Painful shock, loss of muscular control, and in men, 9 to 30 milliamperes. Freezing currents or can't let go range. That's why when you touch a wire or something electrical, you want to use the back of your hand and not pick it up with your pinching fingers, because it may cause you to grab hold and then you can't let go, sure enough. But 50 to 150 milliamperes, extreme pain, respiratory arrest, severe muscular contractions, and death is possible. 1 to 4.3 amps, rhythmic pumping action of the heart ceases. Muscular contraction and nerve damage occur. Death is likely. Hopefully you've got somebody that knows CPR right close to you if you happen to be in this situation. And 10 amps, cardiac arrest, severe burns, death probable. Next slide. Avoiding electrical hazards. Safety tips for working with power on. Keep one hand in your pocket. Wear insulating shoes. Never bypass a safety interlock during testing. Make sure capacitors are discharged. Keep metal objects clear of storage battery terminals. Avoid working on equipment with the battery connected. Sometimes remove unnecessary jewelry from your hands and your neck and your ears and your nose. Avoid working alone. AC safety grounding. The safety ground is a connection to the power system's ground reference connection in your main electrical service box. It's usually green. Sometimes it's bare. The ground connection causes a fuse or circuit breaker to remove power from the cabinet, or from the equipment, I'm sorry. Grounding guidelines. Use 3-wire power cords and plugs. Make sure all equipment has a connection to the ground. Use ground fault circuit interrupter, GFCI circuit breakers and outlets. That's not always possible. In fact, I ordered a small heater this past winter. And when I got it, it was a Chinese-made heater, space heater. It only had 2 plugs, two-prong plug. And I used it anyway. Varying AC wiring is done properly. Never replace a fuse or breaker with one of a larger size. Don't overload single outlets. You probably remember the major prize that the fellow won. It looked like a leg with the end on the lamp. I had a picture of that, but I didn't get it included in this presentation. When wiring circuits, be sure to follow the US standard. Hot, black wire, occasionally red. Neutral is a white wire. Safety or equipment ground is green. Next slide, please. US cable or wire sufficiently rated for the expected current load. And we have a table for that somewhere. Use the proper size fuses and circuit breakers. Be sure fuses or circuit breakers are installed in series with a hot conductor or conductors. And here's a table showing the proper AWG sizes for the allowable current that and the fuses that will work with those currents and copper wire sizes. Lightning protection. Lightning protection is intended to provide fire protection for your home. Starting at your antenna, all towers, masts, antenna mounts should be grounded according to local building and electrical codes. Connections are made at the tower base through a large diameter wire to a ground rod. Ground connections should be as short and direct as possible. Avoid sharp bends because fast-moving electricity don't make turns real fast. Use lightning arresters grounded at a common plate that is in turn connected to a nearby external ground. All ground rods on earth connections must be bonded together with heavy wire. And practice questions.
Hey, Bob.
Yes.
What's the logic behind keeping one hand in your pocket? Is that so you don't hold your hands or you pick up something live with both hands?
That's to keep you from touching something that is electrified and touching ground with the other hand. And that would give you a current across your heart and possibly stop it or causing damage to your heart.
Well, I understand the connection, but it seems like you'd be really hampered to only work with one hand.
Yes, if you're going to use both hands, keep them as close as possible together. So that
in the past, not the modern radios, most transmitters and I guess actually most receivers had lethal voltage in them. And it was really serious not to touch that chassis and a connection that may have several hundred to 1,000 or 2,000 volts on it. And it would kill you immediately.
And sometimes in the past too, working in a kitchen with a stove that had high voltage, it's possible to get a short in the stove and reach over and touch a sink that was grounded real well, and you could end up with electrical charge across your body, and that has caused people to die because of electrical shock.
Do you hear of many injuries now?
I don't hear of as many as I used to, because things on stoves are a lot better than they used to be.
And the one thing that has really helped is the circuit breakers that are now required that are ground fault circuit interrupters will,
Yes,
will flip a breaker before it will supply enough current to hurt you.
Oh. Well,
Believe it or not.
Thank you.
Let me add something. You was talking about having to work with one hand being a handicap. We do the testing and, I mean, if you're going to stick probes in there and stuff, yeah, you do it with one hand. When you figure out what you're going to do and you go work on it, you unplug it, disconnect it, kill the power, and then you can use two hands. But so it's not a total handicap. Just when you're doing live testing stuff, that's when you use one hand.
Well, hopefully I'll always be able to call somebody to come fix the electrical part.
There you go.
Sorry to
Yes.
interrupt your flow.
Bob, if I may add something.
Go ahead.
Well, the idea is that if you're working with a live circuit that's powered, you don't want to complete the circuit to ground. That's what you're avoiding by using one hand.
yes.
Yeah. And another thing to be aware of, the fuses and circuit breakers in your house are there to protect your house wiring, not your equipment.
Thank you so much.
Yes, your equipment has its own fuse to protect it. Okay, that answer your question. Good. Okay, what health hazard is presented by the electrical current flowing through the body? Anybody?
D.
A? Okay, anybody else? D. All these choices are correct. Next.
That is next.
What hazard exists in a power supply immediately after turning it off? D. Charge stored in filter capacitors. And if you're going to touch them or work with them, you need to discharge it. In the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable?
B.
Correct.
Now, one thing that I'm going to mention here is if you do ever get any older radio equipment, the black wire is usually ground in the equipment, but that's kind of confusing. So just to have you aware of it. But in your circuit wiring in the house, yes, B.
What's a good way to guard against electrical shock at your station? Any guesses?
A.
I'd say that's correct. Well, all of them, all three were correct. Making it D.
Yeah.
Where should a fuse or circuit breaker be installed in a 120-volt AC power circuit? In series, in parallel? Which one?
Well, this is cheating because I can see the answer, but it's A.
Well, that's correct. Okay. Where should a lightning arrestor be installed in a coax feed line? Give us a guess. And it's D. On a grounded panel near where the feed line enters the building. Keep that stuff out of the building. Don't need that electricity floating around inside. What should be done to all external ground rods on earth connections? Or earth connections, excuse me, I can't read. Waterproof them with silicon caulk or electrical tape. That sounds good. Keep them as far apart as possible. Tune them for resonance on the lowest frequency of operation. Those all sound good. But bond them together with heavy wire or conductive strap. C. Which of the following is a good practice when installing ground wires on a tower for lightning protection? Pull a drip loop. And make sure all ground wires are bent at the right angles.
D.
Ensure the connections are short and direct.
Again, that would be your C.
Yep. All right, next one. Which of the following is true when installing grounding conductors used for lightning protection? Use only non-insulating wire. Wires must be carefully routed. Sharp bends must be avoided. Common grounds must be avoided. Just
C, the sharp bends must be avoided.
that's what it said back there in the text, wasn't
Yeah. You notice that C down at the bottom, Bob?
it? Mm-hmm.
Okay.
Which of the following establishes grounding requirements for an amateur radio tower or antenna?
A. Nope.
Local electrical codes.
And most of those are comply with the National Electric Code.
Yes, that's usually where they get them from.
Yes.
Managing RF in your station. Your station wiring, feed lines, power connections, and other cables all pick up RF from your transmitted signal. It's not practical to ground RF current in the same way as for AC power and lightning protection. Best approach is to bond all equipment together. Keep all your grounds, all your equipment at the same voltage so that RF current does not flow between the different pieces. RF current on our own cables and enclosures can cause audio distortion, erratic operation of computer equipment, or even RF burns. There's ERT. RF feedback via a microphone cable can cause distorted transmitted audio. Bonding tips. Bond all metal equipment enclosures to a common RF ground bus. Use short, wide conductors such as copper flashing or strap or heavy solid wire. Solid strap is best because it presents the lowest impedance to RF. And a tip from one of the manufacturers, do not use the shielding from coax. It's not as good as solid strap or some of the manufactured, what am I trying to say? the regular, I can't think of what it is.
Bare wire?
Yeah. The one that comes with the eyes on the end of it.
Yeah.
Keep all connectors, straps, and wires as short and direct as possible. And connect the ground bus to your AC safety ground and any earth connections. See figure 9.2 in the text. RF interference, RFI, and filters. Interference between appliances and ham radio is called radio interference, RFI, radio frequency interference, excuse me. Filters are unwanted. Well, I can't read it at all. I need to check my glasses. Filters are used to prevent unwanted signals from being radiated, keep unwanted signals from being received. AC power line filters keep RF signals from passing into or out of equipment via the hot and neutral conductors of the AC power connection. They reject all signals with frequencies greater than a few kilohertz. Ferrite chokes are also used to reduce RF currents on the outside of shielded audio microphone and computer cables. And the ferrite, the RFI buster. And you can see the pictures of the RFI busters. They have many different types of these things where you can wrap them around telephone cords, power cords, coax, and they come in very handy. And there's some other pictures where they show places where they actually place these things. Interference. One of the most useful material in dealing with RFI is ferrite core. It's a ceramic magnetic material. You may have used ferrite magnets. Type of ferrite is used for FI suppression, especially designed to absorb RF energy over a broad frequency range, such as HF and VHF. Ferrite is available in many different mixes, slightly different composition that absorbs best in a particular range. One popular form of ferrite is the snap core shown in the figure. The actual ferrite is a rectangular block, large holes, sawn in half, a plastic case with a snap holds the two pieces together. This allows cords or cables to be wound on the core, even if they already have connectors attached, such as power cords or video cables. Ferrite is available as round cores, toroid rods, or beads, shown in figure 9.4. Wires or cables are then wound on the pass through the ferrite forms. Beads are made large enough that they can be slipped over coax cables, secured with tape or locking wire ties. A wire or cable wound on such a ferrite core form or an RF choke. Interference from amateur transmissions. Most common cause of RFI from your transmissions are fundamental overload, harmonics, and spurious emissions. Very strong signals overwhelm a receiver's ability to reject them, and this is called fundamental overload. Customer equipment is often unable to reject strong signals outside the bands it is intended to receive. A high-pass filter can be connected at antenna input of an FM and TV receivers to reject strong lower frequency signals from amateur HF signals. Broadcast reject filters attenuate signals and nearby AM, FM, and TV broadcast stations. Harmonics, spurious emissions, and leakage. Every transmitter's RF output signal contains weak harmonics of the desired output signal and other spurious emissions that can cause interference to nearby equipment. A low-pass or band-pass filter can be installed at the transmitter's connection to the antenna feed line to prevent harmonics. Leakage is another source of interference. The most common cause of leakage is faulty coaxial connectors on the cable feed line. Be sure the connectors are installed correctly and attached tightly. Good practices in your station. Regardless of the source, you can reduce or eliminate much interference by making sure your own station follows good amateur practices for grounding and filtering. Make sure your station is in good working order with appropriate grounding, filtering, and good quality connections. Use shielding wiring and shielding cables to prevent coupling with unwanted signals and undesired radiation. Be sure to connect the shield properly. Eliminate interference to your own home appliances and televisions first. RFI and neighbors. Start by making sure it's really your transmissions that are causing the problem. Offer to help determine the nature of interference. If you're the recipient of the RFI, make sure your station meets the standards of good amateur practices. Offer to help determine the source of interference. You may have to politely explain to the neighbor the FCC rules prohibit them from using a device that causes harmful interference. Good luck with that. Be diplomatic in dealing with your neighbors, especially if you got some like the ones in Texas. Which of the following conductors is preferable for bonding at RF? Copper braid removed from coaxial cable, steel wire, twisted pair cable, flat copper strap. B, flat copper strap is indeed the best. What is a symptom of RF feedback in a transmitter or transceiver? And we see C down at the bottom, reports of garbled, distorted, or unintelligible voice transmissions. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? It's like a ferrite choke would be the answer to that. Which of the following can cause radio frequency interference? Oh, there's the magic D. All of these choices are correct. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? Receivers unable to reject strong signals outside the AM or FM band. Wow. How can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated?
I'm sorry.
Block the amateur signal with a filter at the antenna input of the affected receiver. Which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? Install a band reject filter. Easy enough. What should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission? Be sure all TV feed line coax connectors are installed properly. Which of the following is a reason to use shielded wire? To prevent coupling of unwanted signals to or from the wire. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? Make sure that your station is functioning properly and it does not cause interference to your own radio and television when it is tuned to the same channel. A simple thing would be to install your antenna for about 2 weeks before you turn your radio on, actually. See if it starts ringing complaints before you turn your radio on. What should you do if something in a neighbor's home is causing harmful interference to your amateur station? Work with your neighbor to identify the offending device. Politely inform your neighbor that the FCC rules prohibit the use of devices that cause interference. Make sure your station meets the standard of good amateur practices. And all these choices are correct. And
all these choices are correct.
and good luck with that. RF exposure. With its relatively low frequency, RF energy is non-ionizing radiation. RF radiation is not the same as ionizing radiation from radioactivity because the energy in signals at radio frequencies is far too low to cause an electron to leave an atom. Can't cause genetic damage. Per FCC rules, the station licensee is responsible for ensuring that no one is exposed to RF energy above the FCC exposure limits. Heating as a result of exposure to RF fields is caused by the body absorbing RF energy. Absorption varies with frequency because the body absorbs more RF energy at some frequencies than others. RF burns can be eliminated by proper bonding techniques or by preventing access to an antenna. And here we have a table and a chart or a table. And the controlled exposure, 6-minute average, showing frequency and the power density, milliwatts per centimeter squared, and the uncontrolled exposure in a 30-minute average with a frequency range, and the magnetic field and power density, and milliwatts per centimeter squared. And
Oops.
yes, it's kind of hard to run back and forth on these. The solid line on the figure 9.5 is controlled, and the dotted line is uncontrolled. And the bottom line is the frequency from 0.3 300
Well, that looks like 100,000 megahertz.
yeah, and up to 100,000.
And the difference between controlled and uncontrolled,
Yeah, is
it means like you have a fence around your property and what's inside that fence is controlled and what's out that side that fence is uncontrolled.
yeah.
But look at your next slides. That's a little bit different, I think.
Yeah.
And people in controlled environments are aware of their exposure and can take the necessary steps to minimize. And people in uncontrolled environments are not aware of their exposure. Areas open to the general public are your neighbor's property.
Those of us who are licensed
Yes.
can be exposed to more than people that are next door. Now, don't try to make sense of that.
And frequencies at which the body has the highest absorption rate are from 30 to 1500 megahertz. And see the graph. An average.
I guess that was that graph we had saw back a while ago.
Yeah. Average and duty cycle, MPE. Limits are based on averages, not peak exposure, allowing exposure to be averaged over fixed time intervals. And transmitters only generate RF for a fraction of the time they operate. Only when transmitting, they receive or set idle the remaining time. This lowers the duty cycle of their emissions. The ratio of the transmitted signal on the air time to the total operating time. Duty cycle must be considered when evaluating exposure. Because the signal is only present for about half the time, or 50% duty cycle, signal power can be twice as high and still have the same average power as transmitting continuously with a duty cycle of 100%. And evaluating exposure, all fixed stations must perform an exposure evaluation. 3 ways of making this evaluation use the techniques outlined in FCC's Office of Engineering Technology Bulletin 65. Measure the power density of your transmissions. Make computer models of your station. Next slide, Eric. You only need to reevaluate your change if you change equipment in your station that affects average output power. The following web page lists resources that makes the job a lot easier. And today, there was a change came up, and you'll need information on the RF signal frequency and power level distance. Give me a roll, Aaron. Can you, well, we'll roll it.
I can't roll it up.
Okay. Maybe I need to get my book. Look it up. 43.
While you're looking for that, Bob, today is the day that we're supposed to all have this done.
Yes. Well, mine's not done. But I'm not transmitting, so.
That's what I was going to say, Bob. You can do yours rather easily. Say, I'm not irradiating, so therefore I'm not exposing.
That's right. My radio is down right now. And I'm rolling my mouse trying to get it to roll up. It won't do it. But anyway. What issue was it?
It says you'll need the information on RF signal, power level, and distance. And why that bottom one can't show up, I don't know.
Probably the answer to one of the questions. We'll find out in a minute.
Let me back up one and see if I can find it here. The way this is working, it's still off the screen on everything I have.
Well, I keep finding the book. I'm looking right at it. You'll also need to reevaluate if you had a new frequency band. Before you start, check to see if your station is exempt from the evaluation requirement. If the transmitter power using PEP to the antenna is less than shown in levels, then no evaluation is required. The FCC has determined that the risk of exposure from these power levels is too low to create an exposure risk. So if you have a 25 watt VHF, UHF radio, you don't need an evaluation of any sort. It's not as complicated as it seems.
Very good. Moving on.
Yeah. Exposure safety measures. Locate antennas away from where people can get close to them. Raise the antenna. Avoid pointing beam antennas where people are likely to be. Use a lower gain antenna to reduce radiated power density or reduce transmitter power. Limit the average power of your transmissions. Place mobile antennas on the roof or trunk of the car, maximizes shielding. Use the remote microphone to hold a handheld transceiver away from your head. Practice question. Seems like we have a lot of those. What type of radiations are radio signals? Ionizing? So have I got an answer? Non-ionizing. D. Non-ionizing. They can't hurt you. Too bad. What do exposure limits vary with frequency? Why do they exposure? Can't read. Why do exposure limits vary with frequency?
That's D.
The human body absorbs more RF energy at some frequencies than at others. What hazard is created by touching an antenna during a transmission? B. Remember,
You can't get a nice burn off of it.
Andy and Barney running around with that old whip antenna on that car. Somebody got burned off of that one time. I forgot who it was. Might have been the goat. The one that ate the dynamite. How does RF radiation differ from ionizing radiation, radioactivity? RF radiation does not have sufficient energy to cause chemical changes in cells and damage DNA. Okay. Who is responsible for ensuring that no person is exposed to RF energy above the FCC exposure limit? You got a license? Guess who? The licensee. And which of the following frequencies does maximum permissible exposure have the lowest value? The 50 megahertz. Isn't that about where 6 meters is at?
Exactly where 6 meters begins.
How does the allowable power density for RF safety change if duty cycle changes from 100 to 50%? It increases by a factor of 2. Does it follow that?
The allowable, that means that you can be exposed to more if it's your duty cycle is 50%.
Why is the duty cycle one of the factors used to determine safe RF radiation exposure levels? Why is duty cycle? It affects the average exposure to radiation. What's the definition of duty cycle during the average time for RF exposure? The percentage of time the transmitter is transmitted. Next. What factors affects the RF exposure of people near an amateur station antenna? They're all correct. Next.
Bob?
Which of the following is an acceptable method to determine whether your station complies with the FCC RF exposure regulations? Bulletin 65. Calculation based on computer modeling by measurement of field strength using calibrated equipment.
Good luck for that.
And they're all correct.
Has anybody ever seen any field equipment that's calibrated for measuring signal strength?
About 25 years ago.
How could you make sure your station stays in compliance with RF safety regulations? By reevaluating your station whenever an item of the transmitter or antenna system is changed. Which of the following actions can reduce exposure to RF radiation? Relocate antennas. Mechanical safety, antennas and supports. Make sure your plans satisfy any local zoning codes or covenants or restrictions in your deed or lease. That's an important one. Place all antennas and feed lines well clear of power lines. And let's add gas lines to that. They didn't have it, but you need to watch that too. A good guideline is to separate the antenna from the nearest power line by 150% of total height of tower or mast plus antenna. A minimum of 10 feet of clearance during a fall is required. Never attach an antenna or guide wire to a utility pole. Grounding rules for antennas and support must be followed according to your local electrical code. Tower should be grounded with separate 8-foot long ground rods for each tower leg bonded to the tower and each other. And before you dig, call ULOCO or whatever the people are that comes out and locates the utilities. Because if you drive a ground rod through a gas line or water line or an underground electrical line, you will pay. Place a safety wire through any turnbuckle, use the tension guidelines. Prevents loosening due to vibration and twisting. Climbers and ground crew should wear appropriate protective gear anytime work is underway on the tower. Be sure to get sufficient training on safe tower climbing techniques before beginning. Use appropriate tie to the tower at all times and always wear an approved climbing harness. Never climb a crank-up tower supported only by the cable that supports the sections. Double check all climbing belts and lanyards before climbing. Make sure all ropes and load-bearing hardware are in good condition before placing them in service. Use a gin pole so that you do not have to hoist things directly. Double check the latest weather report. Avoid climbing alone. And practice these questions. Which of the following is an important safety precaution to observe when putting up an antenna tower? Wear a ground strap connected to your wrist at all times. Insulate the base of the tower to avoid lightning strikes. Look for and stay clear of any overhead electrical wires. I would say C. What is the purpose of safety wire through a turnbuckle used to tension guy lines? B. What is the minimum safety distance from a power line to allow for when installing an antenna? Add the height of the antenna to the height of the power line and multiply a factor of 1 and 1.5. The height of the power line above ground, 1/2 wavelength. Enough so that the antenna falls no part of it can come closer than 10 feet. D. Which is the proper grounding method for a tower? Separate 8-foot ground rods for each tower leg bonded the tower and each other. D. What should you avoid attaching an antenna to a utility pole? Antenna could contact high voltage power lines. Which is required when climbing an antenna tower? D. All choices are correct. Under what circumstances is it safe to climb a tower without a helper or observer? There isn't any. D. Which of the following is an important safety rule to remember when using a crank-up tower? This type of tower must not be climbed unless it is retracted or mechanical safety locking devices have been installed. C. That's the end of module 9. Got some extra stuff I'd like to show you just for the heck of it if you want to see them. If you don't, I guess you could ask questions.
If you have additional stuff that'll help, I'd rather see it.
Okay.
It'll take me a minute to get it up.
That's what she's, excuse me. No, I'm sorry. Didn't mean to interject that. I was thinking about our friend Ralph. Where's our friend Randy at?
He was here earlier. There he is.
There he is. I had a picture I want to show him.
Out of sight, out of mind.
No, not out of mine. You might be out of yours, but
You students haven't figured it out. We have fun with each other sometimes.
okay. Back to the electrical safety stuff. I was going to build a extension cord, and I got to playing around in my junk box and found this. And it was some stuff I'd pulled out of some other stuff, and was looking at some wire, and I pulled this up and looked at it. And I said, well, I'm not going to use that for anything, except maybe salvaging the copper out of it. It's a piece of, it was a extension cord of some kind, or maybe a wire between two different components. But anything like that, you wouldn't want to do anything with it. That's scrap, throw it away. Get rid of it. You go to the next slide, Howard.
So that one wouldn't matter if you had one hand in your pocket or not.
No, just don't never hook that up to anything electrical.
That stuff is kind of a fire hazard too.
Yeah. And there's some of the coating on the outside of the same wire. I threw this back in the junk box. I'm gonna strip the coatings and all that off of it. And if I get down to the place where they buy copper wire, if I get a pound or two of it, I'll sell it to them. Sometimes after you strip enough wire and stuff, you get enough of it. And I had this. It's about 18 inches long. And I thought, well, here's something. I've got a piece of wire with a plug on it. I might just put this jack on it and make myself a short electrical cord. If I had about 12 of these, I'd have an extension cord. So I was looking around, and I had this, and wrong end to put on that one. But I thought, well, I could take a picture of it for this class anyway. Go to the next slide there. And while I had it out, if you notice on these two things have two different color screws to put the wires under.
Yeah, the silver one gets the white wire. The copper one gets the black wire, and the green one gets the green wire.
Yeah. And they don't go, the wire doesn't go exactly under the screw on this one. It's got a sleeve down in the back of it where the stripped wire goes into the back of it. And the next slide there. And this was another cord. It's about 5 foot long that I ended up making. And I should have took a picture of the receptacle on it before I put it together, because the little insulator in the very back of the jack on it, I was trying to put it in backwards, and it wouldn't work that way. And I spent 10 minutes on that trying to figure that out. And finally, I gave up and just laid it aside. Went to something else, came back later and realized what I was doing wrong. And I put it back together like that, and it worked. Next slide, please, Howard. And I'll show you what I did with that later. But I took this little yellow cord and I thought, well, I'll test it and see if it works all right. And I put the ohm meter on it and checked the first wire on the thing, and I read 16 ohms. I thought, man, that's That's quite a bit for that short a piece of wire. And then I went and checked the other side of it, and it read something different. Well, that's, you have to look kind of hard, but it read kind of lower than that other one read.
I'm sorry, that was the meter before you started using it there.
Oh, yeah.
I don't know why that picture came up that small. Let me close out some of this stuff.
Yeah, that was when I had everything just laying out.
There, that better?
Yeah, that's just the meter and that piece of wire laying there with that plug on it. And then, okay, there's the first one. I read one side. It read 111 volts.
0.11 volts, Bob, 1.11.
Yeah. And that looked pretty well normal, I thought. And
That's another wire.
yeah, it's reading one on.
One on.
And I thought, well, that's definitely good. Then I got to the other side, and I thought, well, there's whatever was on that's the problem. And that, I don't even remember what I took that loose from, but it was some sort of an appliance or something that I had taken apart and had that little short cord from. And it's been so long ago that I don't have any idea what it was from, but when it showed me 14 ohms, I thought, well, that was the problem, whatever it was. And then I went back and checked it again today. Let's see, there was one.
And that's after you cut the cord off of it.
Yeah. And there's one other one besides that one. It would give me all kinds of different readings after I cut it off, and that's a piece of an antenna that broke off at some point, and I filed it down to a sharp tip, and I've got it stuck down in the back end of that cord where I cut it off. And at one time, it read real high. And then sticking that sharp point down in that wire, it found a point where it read 1.25. But I've seen it read 64, and one time I read 200. And you could wiggle it around, it'd read just all kinds of stuff. So usually when you take the ground away from anything, especially something electronic, like a disk drive or I don't know, anything electronic. If you take the ground back to AC away, you're going to have problems. I know at one time at work, we got in a PAVX telephone system from one of the vendors. I think it was IT&T over in Tennessee, and they found out they were going to be shut down, and they were shipping the business over to some other country. And the employees found out about it, so they took all the grounds in this whole system and they isolated them with a rubber, and then they put them all into common ground lug and put a crimp on it, and then bolted it down to the chassis of the whole system. And when we got it, nothing seemed to want to work right. You could get it to kind of work, and then it wouldn't. And you think you had it all straightened out, and then it would just go crazy. You make a phone call on it, and about middle ways through it, you'd be talking to somebody else. Just do all kind of crazy stuff. And finally, somebody took that lug loose and checked to see if they actually had a ground, and sure enough, it didn't. So they cut all those wires loose and regrounded everything, and it cured all the whole thing. And so they called everybody else that had that same system and told them what they'd found. And they had done about 10 or 15 different PBXs that way, just because they were being put out of business. And this is a light dimmer switch that I put in a after construction box. And it's got two short cords on it. One's a plug and one's a jack. And if you got something that you're going to plug in that you're not sure of, it's been sitting a while, it got tubes and whatnot in it, you can turn it off and low and medium and high, and it feeds voltage in at steps, so you don't just blast voltage into it, or you can do other things with it. I think Howard has
I have one that I made years ago. I used it to start with a slide projector after I blew a bulb, and a new bulb cost me $50. And 30 minutes later, I blew the second bulb, and that's when I made a box like this so you can turn it on slow, because you always blow your bulbs when they come on right at the input. Also used it to control the temperature in a crock pot when I wanted to lower the temperature enough to make yogurt, which is somewhere around 120 degrees or less. And a lot of different things like that, like the temperature on your on a soldering iron, you can control with it. What you want to look for is the type of dimmer that would run a 1500 amp load.
Yeah, and this one will do that.
1500 watt, I'm sorry.
But it will. This one will do that. It's just in steps instead of continuous.
That's about the coolest thing I've ever heard. A crock pot making yogurt.
Oh yeah, it's but at first I had a cup yogurt maker that you just heat you heat the stuff above 120. It kills all the bacteria in it. Then you cool it down to about 80 or 90 and stir in your live yogurt culture. And then somewhere in about 8, 10, 12 hours, you'll have the whole thing yogurt.
Wow.
And just think, and that's not even a test question.
No, but it's awesomely cool.
Oh, yeah.
Okay, there's a couple more on there. Yeah, let's see. And there it is, kind of wired together.
Isn't that the one where your plug has a bad cord on it there?
Yeah, this is a gray cord, and I had the cord on it, and I had the tester out, and had it all wired up, and rolled it over the next one there. Well, that's one beyond, but there was one with that cord fixed. Even that one was bad too. I finally fixed that cord and put an end in it, and there's that bad plug. I cut it off and marked the leg that was bad. Oh, and that plate somebody, CP&L, power company I used to work for, that used to be in business around Nashville. Somebody cut off a piece of a bus bar. It's about almost a quarter inch thick. They drilled a hole in it, took a number 12 AWG conductor and threaded it, put it in there and sharpened one end of it, had it sitting on their desk to put papers on. They slapped them on there for a paper holder. And there's several people had them on their desk till somebody accidentally stuck one in their hand. And then everybody was told to get rid of them. And I found mine in the trash can. And that's where I got this one at. And the 12 gauge thing that was sharpened, it was in there too, but it'd been taken apart. And I made me a handle to go on it. And I used it for a thing to scratch stuff with. And it worked pretty good. But that little square there works pretty good for a weight. And I think there was one more.
No, I think we're done.
No, there was a couple of pictures I want to show Randy on there. You didn't got them up?
No,
There was a picture with a lightning hitting a tree on there. I wanted to show Randy.
let me look and see if I can find it somewhere, but I never did see it.
While you're doing that, Howard, let me show him my piece of RG 316.
Okay,
That is a piece of RG 316, which is a very small piece of coax. And with your handheld radios, this is the kind of thing that you want to hook up connectors to because it won't break the connection in your radio off. I use this to make an antenna. And according to the manufacturer, now this is American made RG 316. I had Chinese made RG 316. According to the manufacturer, I should be able to put, I don't know, several hundred watts of power into this piece of coax with no problem. I built my antenna, and this is what happened. Turn the radio on. This white piece is the core, and of course you can't see the wire in the end because it's so small. The brown stuff is the supposedly Teflon jacket and the braid. Okay, the brown stuff ends because it evaporated. Okay, I had this hooked up to my 100-watt radio and used it for, I don't know, several months. It was part of an antenna, and I turned the radio on one day, transmitted a signal, and the tuner went crazy. It wouldn't match the antenna, and it had been doing it. So I went outside and, checked all my connections. They're good and tight, and picked the wire up, just started running my handle on it, and all of a sudden I felt a difference. Somehow or another, I evaporated the Teflon jacket and the copper braid. This was what was left. And this is all out of a radio that's running on a 12-volt power supply. So think back when Bob talked about things that you do to keep your antenna safe, like putting it up higher, keeping the ends of your antenna out of the reach of people. That's why there's that much voltage there. And if you happen to be holding that wire, Mona might have a hairdo that looked a whole lot like a scrubby pad rather than what it does now, because it would all be, Bob might either have no hair at all or a whole lot more hair after that happened to him. So but that's just a good example of, again, what Bob was talking about. And I saved that because that totally surprised me, because that cable's supposed to be good for that.
Here's something for you to look at.
Oh, yeah. Don't take your safety lightly. Oh, it can do, like all safety things, the 99 things that you think of and take care of, they'll never happen. It's the one thing that you miss that'll bite you.
That picture is lightning damage to an antenna.
Yeah.
Yeah, somebody just didn't even bother them stainless steel bolts. But man, it was sure ripped that. If there was any water inside that tower, it sure let it out right there. And there was one of a tree there, Howard. Did you see it?
Well, yeah, I've got to do them one at a time there.
Yeah, there it is.
How's that?
Yeah.
Yeah, that's it.
That's why you don't stand under a tree in a thunderstorm.
And it doesn't look like that tree's been hit, but I bet it split that tree wide open.
Well, that thing sure looks awful straight once it gets to the trees, all I can say.
Yeah.
Mhm. I bet it boiled the sap in that thing. And it probably slung bark 100 yards.
Yeah.
That's an amazing picture.
Yeah.
Yeah.
Show that. That they didn't talk about that in the book.
But yeah, that's your grounding and bonding.
Yeah, they don't talk about that in the book. There's a difference. Bonding, they tell you not to do.
That's not really the way that they say to do it.
Nope, not for radios. I was looking at that.
You don't daisy chain it, you do them in parallel.
Oh, that bonding should be run straight down to that.
To that ground.
Yeah. Well, I think the point there is you've got the ground rod over under the electrical panel. That's the one your electrician put in, and that is your house safety ground. And then the other ground rod, if we were hooking that up to our radio, would be our RF ground. And the point is those two ground rods should be connected together.
Yeah, that's the National Electrical Code calls for that.
Yeah.
But that bonding, there should be a bus bar behind all of this, and each one of these points here
Yeah.
should go to it instead of tied together.
Yeah.
The thing that they want you to keep in mind, and I read this in, I don't know, 6 or 8 months ago, there was an article in QST. This radio club was going through their grounding in there. They had a clubhouse, and they had one end of the building was an HF and the other end was a VHF, UHF set up, and they wound up running a strip of copper, I think literally around the outside perimeter of in the inside of the building, and every place they had a station, they had it attached to that. But the point that I had never thought of is when when lightning comes into your radio, okay, that's not a good thing. You want that lightning to have a path to ground before it comes into your radio. Okay. If you don't have your, and I'm not going to use the word lightning arresters because I used to have one when I was a kid, and the lightning hit the oak tree next to the house, and all I found, you know, those little round red things we used to use, Bob?
Yeah.
Well, all I found was the tab that the ground wire was attached to. That was all that was left after that lightning bolt. So, but you want to divert that power to the ground before it gets to your radio. And if you don't have things bonded correctly, the path to ground is through your radio, through that green wire.
Yep.
Back to the power panel. You do not want to run 10 million volts through your radio. It wasn't meant to handle 10 million volts. It was meant to handle 12.
And when you talk about power, and you know we did the watts is equals the voltage times the current. And I have read that there can be up to 2 million amperes in a lightning strike. And when I was in radar school, they said that the gap of a 1/4 inch could jump 10,000 volts. So how many volts do you have to jump all the way across the sky and then multiply that by 2 million amperes?
Yeah. That just gives you a little perspective.
Yeah.
You don't really want to be there.
And lightning, where you got one big bolt like that, if you have something that's conductive that's anywhere near it, will induce a voltage into it that can be terribly high. This could be a fence.
Yeah.
Or your power line or stuff like that. It does not have to be, or your antenna. It does not have to be a direct hit to really damage stuff.
Yeah, keep in mind when we talked about how a radio signal travels through space, through air, you have the electric and the magnetic field. And okay, I'm sitting here with my radio and I'm theoretically putting 100 watts out there. Okay, that bolt of lightning is many, many times my 100 watts. And the guy over in France or Asia or wherever who is hearing my signal, his radio is hearing how many zeros after the decimal in volts, Howard?
Well,
Not very many. And that bolt of lightning has a lot of zeros to the left of the decimal place when it comes down. So that your antenna is my favorite expression is your antenna is the secondary of an air core transformer that has a bazillion volts on the primary.
yeah.
That's that sort of, you know, I'm
Hey, and the ratio
using
is 1 to 1.
hyperbole here, but
Well,
Like I say, the
watching
ratio is
a
1 to 1.
watching a log splitter split wood that's 16 inches long, and seeing how much power it takes to split, 16-inch piece, 10 inches thick or whatever, takes a pretty good bit of power. And then you realize how much a strike from lightning hit an oak tree, a full standing oak tree, and run it down through there, and it goes from top to bottom. And I'm not sure the lightning did it or it just heated the
yeah,
sap up and caused it to split itself.
it exploded.
Yeah. And
Well,
it threw out a strip of bark, a good 50 or 60 feet, and slapped it up against the building. I guess somebody would have been hurt if they'd been standing there, but. And then it got onto the cable that was running pretty close to it and destroyed a phone system and several other pieces of equipment inside the room.
Yeah.
But it's,
I'm pretty sure that I had a lightning strike that was close but did not hit my house. It took out a satellite TV receiver, 2 televisions, a phone, half the phones, and I had an antenna tuner hanging off of a 450 ohm line inside the window, and the circuit traces off of that board, the copper was embedded in the wall.
yeah. Yeah, it's amazing how much power there is.
Yeah.
And most of you may not know what RG8 is, but it's about the size of my little finger. And I used to work for a radio company in the Great Smoky Mountains. They had a repeater, and they had a direct lightning strike there. And that piece of coax about the size of your finger made a hole through a block wall the size a basketball could go through. And there was no copper left in the conductors. Everything just vaporized.
Yeah. Now that we have scared you sufficiently, don't worry about it. But yes, do worry about it. Take care.
Well, now let's move right on and have questions. Anybody got any good questions? I don't care if they're bad questions. We need a few questions. We got a few minutes.
Yeah.
So what do we do going forward? Just study everything that we've learned and then set up an appointment?
Yes. And as far as the appointment's concerned, you live in Haywood County, right?
Jackson.
Jackson County.
That's okay.
A little bit farther, but Western Carolina Amateur Radio Volunteer Examiners are at the Ingalls across the street from the Outlets Malls there on I-26 right at Asheville. About every Friday morning about 10 o'clock and are available to give a test.
And that guy up there called Randy.
Uh-huh.
You want to talk to.
Okay.
Turn your face on, Randy.
Hi, Randy.
All right, what you will need to do is go ahead and get your FRN number through the FCC. It's an automated system. This is for everybody, okay? Except Caitlin and Liz and who else? Benson, they've already got theirs. But go ahead and go into the FCC, get your FRN number, and print that off and keep it. That's your ID with the FCC.
FRC?
The FRN.
FRN?
Yeah. And it's in the CORES, CORES website, FCC CORES website. And print that off. That's your ID. That's with yours from now on. And then when you go to test, you'll need a photo ID, driver's license, and depends on who you test with. With us, it's $10. Certain other, it's 15, and certain others, it's 20. So, but basically FRN number, photo ID, and $10. And when you're ready to test, shoot me an email. Let me know which Friday you want to come in and test. And for the other guys out there, go in and do a Google search or go through ARRL and find a club close to you that offers the test and get in touch with them. Mike, yeah, David, you guys can do that. And get in touch with those and see how much they charge for the testing. But
I'm
basically,
sure-
you'll need your FRN and photo ID.
I'm sure that Dara is going to has that. They're a very active club up there, and maybe we'll get to see you at the Hamfest in Dayton. I plan on being there.
Well, then I guess we'll have to plan on doing lunch at a minimum.
Well, you know what I look like. There's not a whole lot of people that look like I do. So,
Thank goodness.
but
One
you
thing-
know, I plan on going up, spending at least one day in the museum before I go over to the Hamfest too. So, but
Yeah, both places are about 10 minutes or so from my house.
it's
Not too far away.
What's your wife fixing for lunch that day?
Oh, I do all the cooking.
Oh, is that good or bad?
That's good. If my wife cooked, I'd be skinny again.
Oh,
And I've said that with her standing next to me and I'm still alive.
I will say something about finding a test place. The ARRL website also lists Hamfest, and a number of those offer testing during the Hamfest. So that's what Caitlin and Liz did. They went to a local Hamfest and did their testing there. So
Now, Mike and David, you guys are welcome to come to Asheville and test with us if you want to. We had a guy a couple of weeks ago down here from Canada testing with us. Although he is from the area and come to see his folks, but he still tested with us. And, you know, with us, we've had them come in from as far as almost 200 miles away to test with us.
Yeah, we had Nick's grandson. Where was he from? Illinois?
Yeah, I think so.
outside of Chicago.
So, but seriously, you know, do a Google search, ham clubs in your area where you live, and get in touch with them about the testing, and they are tremendous help, and they can give you all that information.
And I think they're also doing free testing at Hamvention.
Well, that's great. Good.
Yep.
Jim sent me the link a couple weeks back.
Okay.
Well, good job. Like I say, have you been to the Hamfest there at Greene County Fairgrounds?
I have not, no.
Okay. They have a nicer facility than what they used to have. I've been going up there for several years now, and it's nice. The old hockey rink was getting in bad shape. The Hera Arena.
Oh yeah, because it was down by UD, I believe, is where they used to have it.
Well, they had it at Hera for a long time. It was, I think, northwest of Dayton over there.
I'm trying to recall. Yeah, because there was a while there, I thought it was the Montgomery County Fairgrounds they were having it at, but I could be remembering incorrectly.
I have only been going for about the last 15 years.
Okay, so I'm remembering incorrectly then. Yeah.
And it was, they're a lot farther back than that, but it's, I think at one time when they started, they were at a hotel in downtown Dayton. But I think they fairly quickly outgrew it.
I think that was before I lived in Ohio, so.
And also, I will encourage, even though you haven't studied for it, not prepared for it that much, but after you pass your tech test, go ahead and take your general. There'll be no additional charge for that. But the reason why all of us suggest that is you get a look at the general test and know what you have to prepare and study for. But go ahead and take it. And, you know, we've had, well, Caitlin, Liz, Benson, when they went in to take their tech test, they took their general and also passed that. So go ahead and take it.
And do get your general. That's where the real fun starts.
Yeah, it is.
That's what my son did. They even offered him for they said you can test on all the different classes, but he did his technician in general and passed both of those.
Yeah, it's as I say, amateur radio has something that can interest you for at least 60 years, I know. I have been at it for 61.
Well, if I can do it for 60 years, I'm going to be a really old person.
I know what you mean.
Yeah.
Nothing wrong with that.
I say that because I'm starting a lot later in life, I think, than you did. So,
Yeah, I think I was a sophomore in high school when I got mine.
okay, yeah. To be a sophomore in high school again.
Yeah, that was a while back. One of my friends that died, it's been almost 2 years now since Ralph died, but we actually played chess on 10 meter AM after school.
Oh, wow. Yeah, my son's big interest was in getting his ham was some of the digital stuff that he can do with computers.
Oh yeah.
So
Oh, yeah.
There's once you have the license, it's almost unlimited what you can do with it. There are frequencies just for remote controlled model airplanes. And, you know, the general run of mill people aren't on those frequencies that are running their airplanes. Only the amateurs are allowed on those frequencies. So it, you know, it's a plus. Well, if we're about done, and Rick, I think is going to have a demonstration for us next week. And if in studying you find anything else you want questions about, we will have one more next week for questions of any kind. If you want to ask about what brand radio that you think you'd like, if you want to get you know, what kind of antenna you think you might like, anything like that. We can give you an opinion if it's wrong.
They go cover chapter 10.
Yeah, that's next week. There's only 9. Don't scare them, Bob. They thought they were finished.
But my book's got a chapter 10.
We will.
That's the table of contents.
Oh. I thought that was.
Actually, I think 10 is the question pool itself.
Yeah. Yeah.
Somebody stuffed something in my.
Oh
Howard?
yeah, there's a lot of stuff in yours.
Yeah, there is. I forgot to tell them, and I forgot what it is. What's these two little holes in this plug for? Do you remember?
That's so you can run a screw through there so you can't plug it in the wall by mistake.
I've seen people put sorter in those holes. It caused people some excitement. And I see people offering to explain what that is, but I never do stop and read it.
Well, I did one time, Bob, and what it was it was a hook for 10,000 ads on Facebook. After about 3 clicks, I says, okay, forget this. So I still don't know what those holes are for, other than putting a screw in there so you can't plug it in the wall. Either that, or depending on how the socket's made, it might create a good short circuit.
Well, now think of this. If you make 10 million of them, it saves copper.
Yeah. Well, you know, that old story when Rockefeller went through the plant where they were canning motor oil and watched then they soldered the lids on, and he asked the guy making the solder, could you do it with one drop of solder less? And the guy says, well, let me see. And he did. And that added, after some period of time, several $1 million to Standard Oil's bottom line. So that may be the best answer.
Well, during World War II, they started leaving out the copper out of the ground of the cord going to electric ranges.
Yeah.
And one of my cousins, they had an electric range in their house, and every time you touched it, you get shocked, and the electric clock didn't work. And for some reason, the stove was sitting right under the little electric main panel coming into the house. It wasn't like 60 watts or something, 60 amps. And I said, well, why don't you take a jumper and tie it to the stove and hook it up to the panel and see if that stops you from getting shocked. And he did. And so he got to checking, and he pulled that cord loose and put an ohm meter on it, and found out he had 8 inches of copper in that cord for the ground. And he got further checking, and it went all the way back to World War II when that cord was put on there, and they had stopped putting copper in the ground wire on the stove during that time to save copper.
That sounds as bad as when it used to be electrical code, where you, on a 3-way switch, you could use the neutral as a travel wire.
Yeah.
And that was, I mean, our house was built in 2011, and they did that, and I was adding smart switches, and I can't do it on the 3-ways because it needs 4 wires, not 3 for the 3-ways.
Yeah.
2011. Wow.
But electrical codes changed, and they can't do that now. My second oldest is an electrician, so he bores me with all those interesting stories.
Well, I'm an electrician myself, so I understand.
Who just should have took a picture of the 3-way switch, Howard.
3-way switches are interesting.
Yeah. What's really interesting is in my living room, I can turn the overhead lights off from 3 different places. That's a really interesting set of wires in there.
You've got 2 3-ways and 1
Yep.
4-way.
Yep. Yep.
Which one's got the 4?
I
One
think
in
it's
the
the
middle.
one in the middle. I found that out when I put a transfer switch in so I could hook a generator into the house. And I was trying to identify the circuits that I wanted to hook up, because my generator won't run the whole house. So I had to decide which circuits to hook in there. And I was trying to figure out, I wanted those overhead lights to work. And I'm sitting there thinking, I got 3 switches in here. So I pulled all that stuff out of the wall and looked at it, and then I Googled it. Found out the electrician knew what he was doing. And the good part about it was, as long as I didn't touch anything, it was all done right, and I didn't have to worry about it. That was the good part.
Oh, yeah.
Yeah. So Howard, what are your thoughts on the stabs on the switches and outlets? Like for stabbing the wires in the back, do you like that, or do you prefer the screws?
I think you better get a better connection with the screws, but you know, it's UL approved.
Yeah, except for every switch and outlet I've had replaced in this house, and I've been having my son do the work.
Yeah.
Every time he pulls one out, it's because of the way they stabbed him in the back.
Yeah.
So we've been slowly changing all of the outlets on a house that's not even, it's not even 12 years old at this point, and we've been changing it all out
Well,
room by room.
I understand, and theoretically, you ought to come up to code it with every circuit you touch. And nowadays, that means a child-proof, arc fault, ground fault circuit.
Yeah.
Yeah, I mean, we had the child-proof ones with the what do they call those, safety outlets?
Yeah,
Yeah, we had those in the house, but like an outlet will become loose from plugging and unplugging things over time. And he says, well, that's because I didn't do this right and that right. And he pulls it out, and sure enough. And
yeah.
so I've been going, and for like all the light switches, it's other than the 3-ways, we've switched them all to smart switches.
Well, I am presently just running a circuit to an overhead fan that I never had in the living room. So,
Guys, I'm gonna have to go QRT here, get ready for something else. So we will see y'all next week.
yep.
Night, gentlemen. Thank you.
7-3.
Stay safe.
I think I'm gonna go find something to eat. So,
Uh-oh. That's why I was muted so much. I was chewing on pizza.
I may have to go
Thank
go
you.
bake
Good night.
bake a pizza. We'll see.
Hope everyone has a good evening.
7-3.
And talk to you tomorrow, Bob and Randy.
All right.
Yep, sounds like a winner to me. And we got our club meeting tomorrow, don't forget.
Yeah, club meeting tomorrow night.
Take care.
Yep.
You lost your voice, Randy.
There we go. I've got the 5 copies of door prizes to print off from Alpha Antennas. They give us 5 $100 gift certificates to use at our Ham Fest for prizes.
Well, that's cool.
Good enough.
So I'm going to print those off here in a few minutes. Everybody take care. We'll talk to you guys in the morning.
Have
All
a
right.
good one. Bye-bye.
Bye bye.